All right, so given this function, okay, find dy dx, which is the derivative of this function. So what you do is you write solution, okay, you let u be equal to the function inside of this trig function, which is 3x squared plus 5. So your y will become 2 cos u. And then you find du dx, which will be given by the derivative of this function expression here, 6x. And then you find your dy du, because now y is a function of u, you get negative 2 sine u. So your dy dx is given by the product of dy du times du dx, or you can also write du dx dot dy du. Okay, so what is your dy du? It is this negative 2 sine u times, what is your du dx? Is what? 6x, which you can write as negative 2 times 6x, negative 12 sine u. But what is this u here? We don't know it. It is our u is 3x squared plus 5. So you're going to substitute back. This should be x. So you should have minus 12x sine, what is your u? 3x squared plus 5. This is the final answer. But from this, you can quickly learn that when you're finding the derivative of a trig function with a function inside, what you do is you simply differentiate what is inside, okay? What is contained in the trig function, then multiply it by the coefficient here. So what I'm saying is that to find dy dx first, you just differentiate what is inside here, which is going to give you 6x times the coefficient. You're going to get 12x, then times the derivative. Now the derivative of cos, which is negative sign, times, so it's going to give you negative sine 3x squared plus 5. Then you just simplify, so you get negative 12x sine 3x squared plus 5. And that's how you differentiate this trig function. Let's do another example. So now differentiate y is equal to cot 4x squared plus 1. So what you do, you write solution first to show that you are ready. And then from here, we know that the derivative of cot x is equal to negative cosec x squared. Okay? Negative cosec x squared. So therefore now the derivative of this function dy dx will be given by the derivative of what is inside of the trig function, which is, if you differentiate this, you're going to get 2 times 4, 2x, oh, sorry, 8x. You get 8x, then 8x times the coefficient here. You should get 3 times 8x. This 8x comes from the derivative of what is inside here. Let me repeat that. This 8x here comes from the derivative of what is contained inside of the trig function. Then times the derivative of cot, okay, of cotangent, which is given by this definition. So this derivative will be given by negative cosec of what? 4x squared plus 1. So these are the brackets. Then from here now, you just need to expand and simplify. So 3 times 8, are we getting? Getting 20. 4x times negative, negative there, and cosec 4x squared plus 1. Plus, is it plus 1? Yes, plus 1. So here we're supposed to have a 1, then you close the bracket. So this is the derivative over our, yeah. So the question is saying that differentiate this equation. Okay, we are talking about with respect to x. With respect to x, differentiate it. So how do you deal with such trig equations? So what you do is you introduce the logarithmic function, the natural log, on both sides of the equation. So introduce the natural log of sine, okay, pi x plus 3, then power y, natural log cos pi y plus 3 power x. Then from there, from the properties of logarithmic functions, this power here can come behind the log here, and then you have log of sine pi x plus 3 equal to, equally this x can come here, and you have cos pi y plus 3. So what we're looking for here is dy dx. And the function that we have now is an implicit function. So we differentiate each variable. But what we'll be doing is that whenever we differentiate y, we'll be writing dy dx to eliminate a certain procedure of dividing through by dx. So differentiate this part. First of all, with respect to y, you should get, keeping this other expression constant, we're going to get ln sine pi x plus 3, then you write dy dx, because the derivative of y power 1 is just a 1. Then plus, now differentiate this second part of the function, keeping y constant, should have y derivative of sine. Okay, when you're differentiating a logarithmic function, you should differentiate what is inside, then divide by what is inside of the log. So derivative of what is inside is simply cos of this. But this sign also contains another function inside, so you're going to differentiate this as well. Okay, then you end up with pi cos pi x plus 3, everything over sine pi x plus 3. Okay, we have that. So this is the derivative of this first part. Then everything is equal to, differentiate the first part here, you have the log of cos pi y plus 3 plus, then plus, keeping the x constant, differentiating the second part, we are going to have derivative of cos is of course negative, but first differentiate also what is inside here. You're going to have pi sine pi y plus 3, okay, then everything over cos pi y plus 3, yeah, cos pi y plus 3. Then since it was a derivative of y on this part, you're going to write dy dx. Okay, then from here it's a matter of making dy dx the subject. So let's do that. Let us do that. Dy dx should be made the subject. We are going to have, so this part, okay, with a negative can go on the other side of the equation. Then we should have ln, okay, ln of sine, okay, the tan over pi y plus 3 dy dx being equal to, this will be taken this side to come this side. Then we can write this as a cotangent. Okay, so we can have, let me write this one first, natural log over cos pi y plus 3. Then I'm writing minus y pi cot of pi x plus 3. So we're making dy dx the subject, so factorize dy dx, then divide by that. We're going to have, factorizing dy dx, we are going to have, we are going to have, we're going to have dy over dx outside, factorized. Then we have natural log of sine pi x plus 3 plus x tan pi y plus 3. Okay, then everything here is equal to natural log of cos pi y plus 3 minus y pi cot pi x plus 3. So divide through by this, so your dy dx will become, dy dx will be given by this natural log of cos pi y plus 3 minus y pi cot pi x plus 3 and everything over natural log of sine pi x plus 3 plus x tan pi y plus 3. This is the final answer to our problem. If you like the video, subscribe and share. Also, you might consider liking this video.